Hey guys, welcome back to Quadratic Equations Functions Revision. Here we are on problem solving, and up to the stage we covered about 4 problems. So actually 5 problems here in a row, and then we go to the problem 6. Here is an object thrown to the air with initial velocity 50 meters per second. The height which the object reached after t seconds, after the throw, is given by the following function. So obviously, who very strong in physics and actually mechanics, projectile motion, he's aware that actually this works as the quadratic function. So h from t is given by, just put a formula for displacement, which is ut plus at squared over 2. In our case, we can combine with physics, and I'll show you why is that the reason for this equation. So if I input, let's say, a vertical height axis, and this is the ground position, so it's the origin, you can notice that the acceleration of free fall in this case is g. So g value is about 9.81. So in many problems you can take as 10 meters per second squared. Alright, so u stands for initial velocity. In our case, initial velocity is 50 meters per second. So actually that's why you have this sort of equation. In our case, h from t, so the height, how depends on time, is actually u, which is initial velocity times time. And because we have a that's negative against your h-axis, so it goes vice versa. So, and if you divide 9.81 over 2, so if you round up to 1 decimal place, 1 dp, it's going to be 9.8, and you divide by 2, you get 4.9 t squared. Alright, so that's the origination. So I'll explain it quick how it comes from the physics. So it's cool if you can combine like with physics, all your knowledge, you got it from there, and you transfer it straight to math, because sometimes math you can see applied math right there. Okay, so that how you explain the formula, so using the physics. All right, so what are you gonna do? Calculate the height after 3 seconds. So what are you gonna do for the first part? So the first part is calculate the height after 3 seconds. So you just simply need to put 3 seconds and your time in seconds, so that's okay. And just simply calculate the value for function from 3. So we've got 50 times 3 minus 4.9, and so t squared is going to be 3 squared, which is 9, right? And now if you calculate that, let's see, 150 minus 4.9 times 9. All right, so we've got 105.9 meters. So what it means, initial speed is pretty fast. It's pretty fast speed, so it goes up, and that's why up to 100 meters after 3 seconds. Can you imagine? All right. So we've done the first one, so about the second one. Calculate the time which the height is the maximum. Okay, so what do you know about a maximum? What do you know about a maximum? So this is actually quadratic function if you consider height from time. Okay, so I set up the x. So in this case, it's h-axis and let's say time axis, right? So in your parabola, if you start investigating how it looks like, so 50t, if you factorize, yeah, the best way is to factorize. So you've got t, and here's in the brackets you got 50 minus 4.9t, from where you can calculate 2 x-intercept. So x-intercept, we are going to do that right now. So the first t equals 0, and the second one t is equal to, so you equate the second brackets into 0, right? Because we're looking for x-intercept, and hence your height is 0. So in this case, we've got that. However, this is a long way. I just want to show you how the parabola looks like, and the branches goes like, it goes down. So that's why that's your parabola. So that's the second time, which is simply 50 over 4.9. Okay, so yeah, we can calculate the value. This is my demonstration how the parabola goes and how you quickly restore it and describe the shape. Okay, so that's time is actually 10.2. Okay, so 10.2 seconds when you reach the ground back. So that's actually a raise in height while it reach the maximum point. So that's h max. It stays for the y vertex. Okay, and this simply the x vertex. So we can calculate x vertex as the half of that time. So it's going to be 5.1, but for sure you can do that another way around. You just simply remember the formula. However, here we have dependency h from time, so just remember how you're looking for x vertex. In the same manner you can find the t vertex, because in our case that's mass applied, so you need to pay attention to where is the independent variable and where is dependent variable. So independent variable is time, so it's sort of x. Okay, so it's minus b over 2a, and you can do the same and you will get the same value for, so 5.1 seconds. That's going to be the x vertex, or in our case it's going to be t vertex, guys. So anyway, it's x coordinates, so t coordinates in our case. So we are going to calculate the maximum height. So what we can do, instead of using the vertex form, we just simply can plug this value into the h, right? So we know at this time the maximum height occurs, so we just put 5.1 second inside the argument into the function. So we've got 50 times time, so which is 5.1 and minus 4.9, so t squared means times 5.1 squared. Okay, so let's do calculations. So we've got 50 times 5.1 and we subtract 4.9 squared times the square of 5.1. Okay, so let's see. Wow, we've got 127 meters and a half. So 127 meters and a half. Okay, round up to one decimal place, we've got 0.6 meters. That's the maximum height. Okay, this is the maximum height. Okay, we've done 2. That was how it works. Okay, so next one, calculate the time at which the height is at the ground level. Oh, by the way, my god, we did it already, because the time is 10.2 seconds. That's the second time when your body is at the ground. So actually the first time when t equals 0. So we actually killed both questions in a row. All right, that was applications for projectile motion, and there how you use actually knowledge about quadratic functions and about parabolas, about how to find the vertex, about how the parabola actually describes the height behavior of the projectile. Okay, hope you enjoy. Don't forget to subscribe in order to be in the latest updates and a video related to your GCSE successful preparation maths. See you later.